Advanced Math Lesson 21, evaluating functions, domain and range, types of functions, and tests for functions. We're going to try to go as fast as we can. It's a lot of information, but it's not very difficult. So hopefully I can get this all in 10 minutes or less. Starting with evaluation of functions. So right here we have a function, f of x equals x squared plus x minus 10. This is a function. Now to evaluate a function, they want you to determine what this is going to equal if they give you a value. So they say if we have the function of x equals x squared plus x minus 10, they want us to find the function of 5. So all we do is we take this value right here, not anything on the left side of the equal sign, but the right side, and we plug in 5 for x. So if f of x equals that, f of 5 would equal 5 squared plus 5 minus 10. So all we got to do to solve this is we simplified. 5 squared is 25, plus 5 gives me 30, minus 10 equals 20. Ta-da! I have just evaluated this function. Now, they're not all that easy, obviously. Let's look at example 21.2. They say that if f of x equals x squared plus 1, find f of x plus 2. Now they're adding polynomials into the mix. So this changes it up just a little bit. Now, even though it looks scary, we're still going to do the exact same thing that we did with 5. Anywhere that we see x in the equation, we're going to replace it with x plus 2. So what that looks like is this. We have the polynomial, or the function, x squared plus 2, or x squared plus 1, and we need to find the function of x plus 2. So what that looks like is f of x plus 2 would be written as substituting x plus 2 for x plus 2 squared plus 1. From here, we FOIL this. We have x plus 2 times x plus 2. First times the first gives us x squared. Last times the last gives us plus 4. Middle term is 2x, and the other middle term is plus 2x. Combine like terms, and we get x squared plus 4x plus 4. And that's going to be our final answer here. We can't simplify it any further. Oh wait, I'm sorry. Not our final answer. I forgot about this plus 1 at the end. So that foils it, and then we have to not forget about our plus 1, which is going to combine like terms here, which makes our final answer x squared plus 4x plus 5. And that's as simple as we can make it because we don't know a value for x. Next one, they're going to throw some trig problems at us. So we'll look at example 21.3. This looks scary at first because it's a bunch of different symbols, but it works the exact same way. So they tell us that if h of theta equals sine of theta, to find 4 times the square root of 3 times h of 30. So our function is h, and they want us to find out what 4 times the square root of 3 times a function of h with 30 degrees is going to equal. So if h of theta equals sine of theta, then h of 30 is going to equal sine of 30 degrees. So instead of writing h of theta, I'm going to put sine of 30 degrees, and then that times 4 root 3. Sine of 30 degrees means we're going to use a reference triangle. Our reference triangle is going to be our 30, 60, 90 triangle. I'll reference that on the book to save time. So sine of 30 degrees means that we're going to take the opposite, put it over the hypotenuse, which means we're going to have a value of 1/2. So sine of 30 degrees can be replaced with 1/2. Multiply that by 4 root 3. We get 4 root 3 over 2, and then we cancel to get 2 over 1, or 2 times the square root of 3. And that's our final answer. If I went too fast for you, remember YouTube has pause and rewind, so just go ahead and take it back, and you can also play videos at half speed as well. Not sure if you knew that. Just hit the little settings wheel, down here somewhere. It's like on the bottom right corner, and then you can hit playback speed, set it at 1/2. Or if you think I'm going too slow, you can also set it at double speed, in case you didn't already know. Moving on. We're going to talk about domain and range of a function. So we'll talk about this in class, but domain more or less is talking about the distance you can move left and right on the x-axis. Range is talking about what values you can move up and down on the y-axis. Now to find the domain and range of a function, we just have to remember 2 rules. Is 1, we cannot have division by 0, and 2, we cannot have square roots of negative numbers. If you remember our class on negative numbers, you remember that i's don't really have a lateral or vertical value on a number line. They go into this weird zone or realm of imaginary numbers, and so they don't work as well with our traditional number lines or Cartesian coordinate systems. So we can't deal with any negative radicals or anything that gets divided by 0. That's going to determine our domain. Now let's apply that to a function. For example, this first one, 21.5. There we go, straight. Okay, so we're looking at 21.5. So all we have to do is, since we have a fraction in our function, we have to find out what values of x would make this fraction or the denominator be 0. And we know that 2 minus 2 is going to equal 0. So x can be anything except 2. We can have a negative, we can have a positive, but we cannot have 0. So if x is 2, then this function does not work. So the domain is going to be x cannot equal 2. So the way we write that is we would write domain of G equals the set of x being all real numbers as long as, I just realized you can't see what I'm saying. So we write domain of G equals the set of x being all real numbers as long as x does not equal 2, end set. So just write D of function G equals the set, and we signify a set by using braces. So brace, and then we put a criteria. X can be all real numbers. It can be anything positive, anything negative. It can be decimals, etc., as long as it is not 2. And that's the end of our domain. The other example that's really simple is they give you the function of y equals square root of x. Well, like I said, we cannot have negative radicals. So on this, the domain of y is going to be the set of x being all real numbers as long as x is greater than or equal to 0. The reason why is because x cannot be any negative number. If x is ever a negative number, this does not work, so we cannot do it. Now, your homework's never going to be that easy. They'll have crazy problems like this. If we have the function f of x is equal to the square root of x, let's see here, x plus 4 over x minus 2. All right, so let's make this a 3 just to change it up. All right, now the first thing we see is we see a fraction and a radical. So we'll start by writing the domain of function f equals the set of x being all real numbers. That's going to be a common trend in your domains. You'll get used to it. As long as x does not what? Well, x cannot be 3. So we know that's one criteria. X cannot be equal positive 3, or else that would give us a 0. Now, what about this radical? You think it's positive. How could it ever become a negative? Well, if x has a negative value, this could be a negative. For example, if x were negative 20 plus 4 would give us negative 16. So what is the highest negative? And we can't just say negative period, because negative 1 plus 4 gives us a positive number. So the highest negative that x can be is negative 4, because it's okay to have 0. So x can be equal to or greater than negative 4. So this one's going to be x is greater than or equal to negative 4. And that's our two criteria. And the way we put both of them in is we just go to here and we'll put x does not equal positive 3, comma, or x is greater than and equal to negative 4, end set. And that would be how we write our answer. The very last thing, we've got 1 minute to go, and I think we can pull this off, is types of functions and then distinguishing a test for functions. So, going to the book, we have two types of mathematical statements here. We've been talking a lot about functions. What a function means is that for every x value, there's only one y output. And they can be the same y as long as there's only one x value. So each x can only have one y. So for a function to be true, for every single point that this image shows up on the graph, each x has only one y value. Now, a relation is something that has two y values for one x. So this one would have the point 4, 3 and 4, 5. This is not a function, it's a relation. Now a function, it can have multiple x's on one y, but it cannot have two y's for one x. So remember, domain is x-axis, range is y-axis. Now, here we have not a relation. In this case, not all the x values have a partner. So that's not a relation. And then here, what we have is called a one-to-one function, which means for every x, there's only one y. And those are very similar to like our linear equations. There's only one y value for each x. The way we test that is the way that we test functions is with a vertical line test or examination of points. So, examination of points can be pretty simple. We see here we have two x's with one y, so this is not a function. Here we have two x's. Or wait, I'm sorry. Correction, this is a function because we have two x's with one y, but no more than one y for any x. Here, this is not a function because we have two y values for one x value. Here, this is not a relation, not a function, because there's an x value that's missing. Here, this is tricky. So x is the subset of all reals, y equals x plus 2. D is a function. This is going to become a linear equation. It works. Any value of x that we put in there will only have one output for the y. So those are separating different types of functions. Now to test functions, we have these two types of tests. The first one is called the vertical line test. This will tell us whether or not anything is a function. Now, like I said, if it's a true function, each x point only has one y value. So if we ran a vertical line across the function, it would only touch the graph of the function at one point. Whereas here, we run the vertical line and we hit 2 points at multiple areas, which means that's a relation and not a function. Lastly, we can test whether or not a function is a one-to-one function by using the horizontal line test. If a function passes a horizontal line test, it means as a horizontal line goes down the function, it only touches it at 1 point. Whereas here, this is a function, but it's not a one-to-one function because we have two y values for the same, we have two y values for different x values. And that's how we test functions: vertical line tests, horizontal line tests, and then examining the points themselves.